Alrighty class, so today we're going to learn a little more about earthquakes. Do you remember how yesterday we learned about normal faults? Today we're going to learn about two more. I want to start off our science lesson by reviewing a little bit, but first let's talk about what we did yesterday for our jitter release. Do you guys remember that we all stood up and we pretended like we were the ground moving around, so we went, whoa! Well, today I want us to all stand up. You guys can go ahead and do that now. And we're going to pretend like we're something on top of the crest, so the ground's moving underneath us. So you guys can be buildings, you can be big trees, you can be little bitty trees, or little buildings, okay? So we're going to have 7 seconds, and we're going to get all our jitters out, and we're going to pretend to be something moving on top during an earthquake on top of the Earth's crust. Are you ready? Here we go. Whoa! Whoa! Shake, 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 shake. Whoa! Okay, we're done. Good job. All right, so let's all focus back up onto earthquakes so that we can learn a little bit about what happens underneath the earth. So I want you guys to focus on 2 key words that we'll be talking about, and that'll be reverse and then streak slip. So as you guys can see, those are our 2 questions for the day. What is a reverse fault? And we learned about faults the other day, so we should all know what those are, right? The cracks in the earth where the crust meet. Okay, so what is a streak split fault is our next question. So let's keep those in mind as we continue our math lesson. Sound good? Now, when answering what is questions, what do we learn about language arts the other day? When it's a what is question, to fully understand it, we would need to have at least 3 details, because 3 details is just about the right amount for so that we know all that we can about our topic. So, here's my question to you guys. We know now, after we acted it out, how things react whenever the ground underneath it's all shaky, we kind of wobble back and forth. But has anyone ever felt an earthquake? And do you guys know anyone who has felt an earthquake, who has been in an earthquake before? Yeah. If you guys have family members or friends who live in Alaska, California, or Hawaii, which are states in the U.S., they've probably experienced an earthquake, because earthquakes happen there a lot. Whenever it comes to the United States. But we know from the other day that earthquakes happen all over the world, right? Yeah. Okay. So, we're going to review, remember like I said, we talked about faults the other day. So faults are stress in the earth, where the rocks that we stand on, which is the crust on top of the mantle, has broken. And this is where those broken pieces pass each other. A little bit like this, which is the crust moving back and forth. So we also learned yesterday not only what fault is, but we learned about one type of a fault. Can you tell me what that is? Right, it's a normal fault. So normal fault is whenever the hanging wall has moved downward in relation to the footwall. And the footwall was the one that looked like your foot when you were pointing it, right? So if we're the hanging wall and the footwall, the hanging wall is going to move down, kind of like this. Remember, we did that activity? Yeah, all right. So, we're going to learn about different types of faults. So, like I said, we learned about this middle one yesterday. That was a normal fault. So, the first one we're going to go over today is a reverse fault. Can anyone tell me what reverse means? Because, to me, reverse is kind of like not forward, right? It's going backwards. So, we learned about a normal fault, so now we're going to learn about a reverse fault. So let's kind of brainstorm a little bit about what that could be. If you look at the picture, it kind of gives you an idea. A normal fault is whenever the hanging wall goes down, and in a reverse fault, it's the opposite of that. So it's when the hanging wall goes up. Does that make sense? See how it's kind of the opposite of a normal fault? So a reverse fault, the total opposite of a normal fault, right? So the hanging wall rises instead of falling next to the footwall. So that's just the difference in the pressure of what's happening underneath the crust. excuse me. So this different fault occurs when it's under a lot of pressure, which we talked about what happened from the heat underneath the mantle and how that changes. But a note, just like normal faults, reverse faults only happen in vertical motions. And vertical is up and down. We've talked about that in math a little bit, haven't we? Yeah. All right. So those are some important things that we need to know about reverse faults. That they're the exact opposite of normal faults. So they go, oh, this rhythm's I forgot. They go up. There we go. And they occur under a lot of pressure, just like normal faults, but they also only go up and down. So I want to show you guys this. We're going to look at some pictures of a reverse fault here. So there's one right there. And if you can tell, this is the footwall here, and the footwall has risen up over the hanging wall. So you can tell that by this gray, or well, it's tan, by the tan rock there. You see how it moves from down here, it would have been a straight line, but because it's had a reverse fault, it's moved up. Let's see if we can see that in the next one. We sure can. In the next one, we can see that this line here in the rock and this line here don't match up anymore because this side of the rock has moved up. A little note, reverse faults can happen on both sides, just like normal faults. So they can go right laterally or left laterally. So it doesn't matter what side goes up and down, but the footwall and the hanging wall stay the same because those are dependent on the shapes of the rocks, but the motion is still different sometimes. So our next fault, like I said, is going to be our strike-slip fault. So these ones are a little different. These ones don't move up and down vertically, like we've talked about with our normal and reverse faults. These ones move horizontally. So instead of our rocks moving like this, they're going to move like this. Up and down, forward and back, not up and down. So the best way to look at these, like the pictures we had before, we were kind of looking straight at the rock. But if you're gonna notice a strike-slip fault, you're gonna want to look up from the air. Does that make sense? Because they're gonna move up and down. They're gonna move side to side. They're not gonna move up and down, so it'll be harder to notice. Also, in strike-slip faults, they can happen in two different directions. They can go left, which means the left one moves away from the right one, or they can go right, which means the right one moves away from the left one. These pictures kind of demonstrate that really easily, don't they? They create changes in the landscape more often than the rocks, because a lot of the time in the rocks you just saw that the rocks change different colors, but during strike-slip faults, they can move streams a little bit. So a stream can be like this, and then it can go like this, and so then the stream could be like this. The strip fault would happen, and it would move one side to the next. The stream would then have to reconnect, so it would change it a little bit to reconnect the dot almost. Instead of being a straight line, it would just be a little curvier. So those are always fun. Strike-slip faults happen also when you are dealing with a bunch of compression underneath the earth. It's just how that compression is released, which is the difference. So here's a little like virtual demonstration of what the earth is going to look like under a strike-slip fault. So you see it's going to crack a little bit, and it's going to move sideways. Now, just like I was talking about the stream earlier, do you notice that it starts off together, the road, and then when the strike fault happens, it separates. So the road is no longer connected. Now, a stream is constantly flowing, so it's going to reconnect itself, but roads don't flow. So roads are going to be cut in half, just like that. Okay, and I have this little video for you guys. These guys are a little younger than you, but they can teach you a lot. And pay attention to how they demonstrate what an earthquake is, because we're going to talk about what kind of earthquake that is whenever we finish up watching. All right, so I want your guys' listening ears on, all right, so that we can pay attention.
Hi, I'm Arjun. I'm Sonia. And I'm Sonia. It is a simulation that shows how the tectonic plates move across rocks. The plates at the bottom of the carbon at the bottom of the box simulates the tectonic plates. The dirt simulates the soil, and the building blocks simulate the buildings. Now we are going to show how the tectonic plates move and cause our dream. If that was a real earthquake, the plates would move really, really slowly. The pressure would build up more and more, and boom! The earthquake happens. Earthquake changed the earth by turning some soil into liquid and breaking the earth by causing tsunamis. Tsunamis are water erosion caused by earthquakes. Earthquakes change the earth quickly.
Okay, and that was the end of our PowerPoint today. But can you kids remember what the cardboard that they had underneath represented the tectonic plates? And then they had some soil, which represented the crust. But then they even had a little building on top, didn't they? Made out of Jenga pieces. So they moved the tectonic plates, the cardboard, just like this, right? So what kind of fault is that? You might have learned about it today. A strike slip fault. That's right. Good job. So a strike slip fault moves back and forth horizontally, right? Perfect. And then what happened to the soil and when they were moving it back and forth? It got all mixed up and jangled up, right? It didn't stay the same. Just like the road in our simulation earlier, it cracked. And what about that building? That building that was sitting on top of the two different tectonic plates, when they moved back and forth, yeah, the building fell down. Now, whenever we were moving around back and forth pretending to be building its trees, we didn't fall down, did we? No, but we sure did move a lot, didn't we? Yeah. There's sometimes, if you're in an area that is used to earthquakes, they can actually build buildings differently so that they can move a little bit just like us, so that they don't fall down. And other times, earthquakes are surprising and we don't prepare buildings like we think they need to, and they'll crumble all the way to the ground. One of the little boys in the video mentioned that earthquakes weren't very slow, and they do happen very quickly. We talked about that before, right? It's not like a real slow happening. It's like boom, and it rattles us all a whole bunch, right? Yeah. So earthquakes are really scary, but they're really fun to learn about, right? Okay. Let's move on to our next lesson for the day. And thank you, Dr. Hazen, for being my teacher this year.